be talking about polynomials, but before we start, let's review over some definitions. So terms. Terms can be a single number or variable, or numbers and variables multiplied together. So for example, 2 can be a term, 2x can be a term, or just x can be a term. Okay, a monomial is an expression with one term, so think of a vehicle with just one wheel. A binomial is an expression with two terms, okay, so a bicycle, bi, so it has two wheels. Trinomial, an expression with three terms, so a tricycle, so three wheels, okay. And a polynomial we'll talk about is many terms, okay, so two or more terms. Okay, so let's look at number 7, our first example. We're going to simplify this polynomial. So our polynomial is 2x squared plus 3x plus 2 minus x squared minus 4x minus 1. So these both have three terms. So 2x squared plus 3x plus 2. This is three terms, so this would be a trinomial. X squared minus 4x minus 1 also has three terms, so this is a trinomial. So you can see the definitions of terms such as x squared, 4x, and 1. Since there's three of them, it makes a trinomial. And we're going to have to subtract these two. Okay, so this is a review of combining like terms. But the first thing we're going to have to do, we have to figure out what we have to do with this minus sign. So we're actually going to say this is minus 1. And we know that if we're multiplying something with a parentheses, we have to distribute it to everything inside the parentheses. So we're going to distribute into everything inside this trinomial. So we're going to rewrite our 2x squared plus 3x plus 2. Then negative 1 times x squared is just going to be minus 1x squared. Negative 1 times negative 4x, we're going to multiply the numbers, or our coefficients. So negative 1 times negative 4 would be positive 4x. And then negative 1 times negative 1 would be positive 1. Now we're going to have to combine our like terms. Okay, so our like terms we talked about is going to be the ones with the same variable and same exponent. Okay, so you initially learned that when you combine like terms, they have to have the same variable, such as x or y. But in this case, they have to have the same variable and same exponent. So let's look at the first term. We have 2x squared. So we're not worried about the coefficient. That's what we're going to perform the operation on. We're just worried about what our variable and the exponent is. So we're going to say this is an x squared. I'm going to label this with a triangle. So I know that anything with an x squared is going to get a triangle. So I'm going to look through the rest of my polynomial and see what else has an x squared. Well, if I look here, this minus 1 is x minus 1x squared. So I'm also going to label this with a triangle. So let's get a different color. So now we have a term with 3 and an x. So we're going to call this 3x. So we're going to look for anything with just an x. But notice this doesn't have an exponent. So it doesn't have an exponent. We're just going to say this is a 1. Okay, so anything with an x and an exponent of 1, we're going to put a circle. So 2 does not have an x. And then we come across 4x. This also does not have an exponent, so this is a 1, and this is going to get a circle as well. And now all we have left is our numbers, or our constants. So we're going to say 2 gets a square, and 1 gets a square. Okay, so now we're just going to combine our like terms, or in this case now our like shapes. So we have a triangle and a triangle that has 2x squared minus 1x squared. And let's talk about what that means. Okay, so we're just going to do what's on the coefficient operations on our numbers. So 2 minus 1 is going to give us 1, and we're going to keep our x squared. We're not going to subtract x squared. So our final answer would be 1x squared. So let's go on to our circles. So we have 3x plus 4x. Okay, so same thing, we're just going to add on our coefficients, and that's going to give us 7x. Then going to our squares, we have 2 plus 1. So that's going to be 3. And now we're going to write this in standard form. So what is standard form? Standard form means you take your polynomial and you write it with the highest exponent on your variable. Okay, so the highest exponent of our variable in this case would be squared. So we're going to first write 1x squared. Then we have a x with an exponent of 1, so plus 7x. And then the 3 does not have a variable, so we're just going to say plus 3. Okay, so standard form means you take the highest exponent or highest degree, okay, off your variable. So in this case, x was a squared, then x to the power of 1, and then 3 does not have an x, so it's going to come last. So our final answer would be 1x squared plus 7x plus 3, or if you didn't want to write the 1, you could also just write x squared plus 7x plus 3. Okay? Okay, looking at number 8, we have 2a cubed times, because that parentheses, 5a squared minus 7a plus 3a to the power of 4 minus a to the power of 5. So the first thing we're going to do is we're going to distribute our 2a cubed to both of our terms. So in this case, it's two terms, so we're going to call this a binomial. So we're going to distribute our 2a cubed into our binomial. And we're also going to distribute this plus sign to help simplify. So what can I put here to see what number's here? Well, there's no number here, so in order to keep it the same, we're going to say that's a positive 1. So we're going to distribute a positive 1 to both of those. So now we have to talk about what do you do when you multiply a variable with another variable. Okay, first we're going to do 2 times 5, that's going to give us 10. Now we're going to have to think about a cubed times a squared. So this is what's called the product rule. Okay, so we're doing a cubed times a squared. So when you multiply a variable with exponents, the product rule tells us that you're going to just add the exponents. Okay, so we're going to say a, we're going to keep our base. Okay, so we're going to keep our variable a, and we're just going to add 3 plus 2. So that'll give us a to the power of 5. So then if we have 2a cubed minus 7a, what do you think that was going to do? So if we were to do this, we would have 2 times negative 7. That would give us negative 14. And now we have a cubed. Well, what is this a to the power of? Well, there's no exponent, so we're going to say it's a to the power of 1. So now we have a cubed times a to the power of 1. So we're going to keep our base or our variable. We're going to keep our a, and we're just going to add the exponent. So when you multiply two variables, you add the exponents. So 3 plus 1 gives us 4. So we have negative 14 a to the power of 4. All right, so looking at our next problem, we have plus 1. So we're just going to distribute. So plus 1 times 3 is going to keep us as 3a to the power of 4 minus, okay, so there's no number in front. So once again, what can we do? Keep it, what number can we put to keep it the same? We're going to put a 1. So 1 times negative 1 will give us negative 1, and we're going to keep our a to the power of 5. Okay? So first we have to label our like terms. So I'm going to start with our first term. So we have 10a to the power of 5. So I'm going to say anything with a variable of a and to the power of 5 is going to get a triangle. Okay, so looking through my problem, this a is to the power of 4, this a to the power of 4, and this a is to the power of 5. So this one is going to get a triangle. Going to our next one, we have 14a to the power of 4. So I'm going to say anything with an a and is also to the power of 4 is going to get a circle. And this also has an a to the power of 4, so that's going to get a circle. So we're combining 10a to the power of 5 with negative 1a to the power of 5. So 10a to the power of 5 minus, because there's a negative in front of that 1, a to the power of 5. So we just said we're not going to do anything with our variable or exponent because we're just doing a subtraction. So we're going to do 10 minus 1 will give us 9a to the power of 5. Then looking at our next one, our circles, so we have negative 14 a to the power of 4 plus 3 to the power of 4, and we have to figure out what that equals. Okay, so doing our integer operations, we know negative 14 plus 3 is going to give us negative 11, and we're going to keep our a to the power of 4. And now we're going to write this in standard form. So we have a to the power of 5 and a to the power of 4. So this is the higher degree. So that comes first. So we have 9a to the power of 5 minus 11a to the power of 4. And that would be our final answer. Okay, looking at number 11, we have x minus 1 times 4x minus 3. So this is a special scenario called multiplying two binomials. This has two terms and this has two terms. So we're multiplying together two binomials. So when you multiply together two binomials, you use the method called FOIL. Okay, so FOIL has some different meanings. So the F is going to stand for first, so you're going to multiply together your first two terms in both binomials. The O is going to stand for outside. I is going to stand for your inside. And L is going to stand for your last. Okay, so let's talk about what that means. So let's start with the F, so our first. So that means in our two binomials, we're going to multiply together the two first terms. So this x comes before the 1, and this 4x comes before the negative 3. So we're going to say this is our first two terms. So we would do x times 4x. Okay, and we just talked about when we multiply a variable to variable, we add the exponents. Okay, so we don't have any numbers here, but we know this is x to the power of 1, and this is x to the power of 1 because they don't have an explicit exponent. Also, we can keep a 1 here to keep our term the same, but we can see what we have to multiply with our coefficients, the numbers tied to our variable. So we have 1 times 4, give us 4, and then we have x and x, we're multiplying, so we add the exponents. So we're going to do 1 plus 1, so it becomes x squared. Okay, so that is our first term. Then we're going to go to our outside terms. Okay, so our outside, we're going to say what's outside of our binomials. Okay, so we have an x and our minus 3 on the outside. So now we're going to have to do x times negative 3. Okay, so this is just joining together because this negative 3 does not have a variable. So we're also going to do 1 here. So we're going to do 1 times negative 3. So we have negative 3 and we have x. So they're combining together. So negative 3x. Then if we go to the inside, say, so we did our outside. So our inside would be minus 1 and 4x. So we have negative 1 times 4x. So we're going to multiply negative 1 times 4. Would give us negative 4. We don't have a variable on the negative 1, so it just becomes negative 4x. Our last is going to be negative 1 and negative 3. So we're going to multiply negative 1 times negative 3, and that's going to give us positive 3, or just 3. Okay, so now we're going to rewrite this in standard form. So let's go back to black. Okay, so x squared, that's our highest exponent. So we're going to say 4x squared minus 3x minus 4x plus 3. Okay? And we can actually simplify this a little more because if you notice, we have an x and an x to the power of 1. So we can combine our like terms. So we're going to bring down our 4x squared. Negative 3 minus 4 will give us negative 7x plus 3. Okay, and we cannot simplify this anymore. So this would be your final answer. So when you have two binomials, so this has two terms, so this is one binomial. This has two terms, this is another binomial. When they are multiplying together, you're going to use the method called FOIL. You multiply the first terms, then the outside terms, then the inside terms, and then the last term. Okay, looking at number 15, we now have a division problem. Okay, so now we have to talk about a different rule called the quotient rule. Okay, so we'll talk about that, what that means. So we have first, we're going to divide each one, okay, in our numerator. So negative 8x to the power 5 plus 28x to the power 4 minus 4x cubed. Each one of these terms, okay, or three terms in this trinomial, has to be divided by the 4x cubed. Okay, so you can even rewrite this as negative 8x to the power 5 divided by 4x cubed plus 28x to the power 4 divided by 4x cubed minus 4x cubed divided by 4x cubed. Okay, so this shows us that we're dividing everything by the 4x cubed because in our original problem, we have this long fraction bar showing us that everything is being divided by the denominator. So let's look at the first part. So we have negative 8x to the power 5 divided by 4x cubed. The way you go about these problems is you divide your coefficients. Okay, in this case, the numbers are negative 8 and 4. We know that's going to give us negative 2. So now we have to talk about how do you divide x to the power of 5 and x cubed. That's where the quotient rule comes into place. Okay, so when you have x to the power of 5 divided by x to the power of 3. So let's talk about that. In our previous problems, we talked about the product rule. So that was multiplication. So when we had the product rule, we added our exponents. Okay, but now we're doing the opposite of multiplication. We're doing division. So now we're going to subtract the exponents. So you see how they kind of do the opposite of one another. So we have x to the power of 5 divided by x to the power of 3. So we're just going to rewrite this as x to the power of 5 minus 3. And that's going to simplify to x squared. Okay, so this would simplify to negative 2x squared. You can also rewrite this in expanded form. So we have x to the power of 5. So we know exponent means repeated multiplication. So we would have x times x times x times x times x divided by x to the power of 3. So we would have 3x's now. And then you would just cancel out. So x can be divided by x. That would be cancel out. X divided by x. That cancels out. X divided by x. That cancels out. And you can see you're left with x squared. So your final answer has to be x squared. So looking at our next one, we have 28 x to the power of 4 divided by 4x cubed. So we know this is going to be a positive because it's a positive divided by a positive. So we're going to put a plus sign. So we have 28 divided by 4. That's going to give us 7. And then we have x to the power of 4 divided by x to the power of 3. And we know we're dividing, so we have to subtract the exponents. So we have 4 minus 3. And that's just going to give us x to the power of 1. So this is going to be 7x. I'm not going to write the 1 because we know it's the same thing. Okay, and then our last one, we have negative 4x cubed divided by 4x cubed. So let's start with our coefficients, the 4. So negative 4 divided by 4 is going to give us negative 1. Then x cubed divided by x cubed. And this is going to be x, 3 minus 3. It's going to be x to the power of 0. Now, what does x to the power of 0 mean? Okay, if anything to the power of 0, we're just going to say is 1. Okay, so if you put that in the calculator, you would say 1 to the power of 0 would just be 1. 2 to the power of 0 would just be 1. 332 to the power of 0 would just be 1. So in that case, since a variable represents a number, x to the power of 0 is just going to be 1. So we can even write this as a 1. And we know negative 1 times 1 is going to give us negative 2x squared plus 7x. And it's going to stay as minus 1. So your final answer would be negative 2x squared plus 7x minus 1.